Hello everybody. Today I am going to discuss about the trigonometry in optional mathematics. Yesterday we discussed algebra in compulsory mathematics, and today we are discussing trigonometry. Most of the students feel very difficult in trigonometry, and today I am giving you some of the easiest way to prove the identities. Okay, now we are going to discussing. First of all, to know the trigonometry, we have to use the different formula like 2 sine theta cos theta equals to sine 2 theta. Similarly, 2 sine square theta equals to 1 minus cos 2 theta. 2 cos square theta equals to 1 plus cos 2 theta. 4 cos cube theta equals to 3 cos theta plus cos 3 theta. Similarly, 4 sin cube theta equals to 3 sin theta minus sin 3 theta according to the multiple angles. And in the sub-multiple angles also we have to use such type of formula, but angle becomes half. Similarly, transformation formula also can be made easier like this. S plus S, it means sine plus sine C plus sine D, it means. And for this S plus S is 2SC. From two way we have to know this formula. 2SC equals to S plus S, and S plus S equals to 2SC. Similarly, S minus S is written as 2CS, just opposite of the first. C plus C can be taken as 2CC. C minus C can be taken as minus 2SS. Likewise, these are the formulas which are mostly used in trigonometry, and if you can use such formulas, then your problems becomes very easier. And now we are going to discussing the different problems identities according to the using of above formula. First identity is sine square theta minus cos square theta cos 2 beta equals to sine square beta minus cos square beta times cos 2 theta. Left hand side, we have to prove from left hand side to right hand side. That's why we are taking here sine square theta minus cos square theta times cos 2 beta. And in the formula which we have discussed here, if there is the trigonometric identity having square, then always we have to take the coefficient 2. And if there are in product form also, then we have to take the coefficient 2. And if the trigonometric identity having power 3, then we have to take the coefficient 4 to make the formula easier. That's why here are the squares in sine as well as in cos. That's why we have to take the coefficient 2. By taking 1 by 2, then we can multiply it. 2 sine square theta minus 2 cos square theta times cos 2 beta. Sorry. 1 by 2, formula of 2 sine square theta, which we are already discussed here, is 1 minus cos 2 theta minus 2 cos square theta is 1 plus cos 2 theta times cos 2 beta Now 1 minus cos 2 theta minus, we have to multiply it by cos 2 beta. Cos 2 beta minus plus minus cos 2 theta times cos 2 beta, 1 by 2. Now in the right hand side, the first trigonometric identity having angle beta, but in left hand side there was, here is the theta. That's why now this one theta and beta we have to exchange here. 1 minus cos 2 beta we have to write at first like this, and this one have to be taken second. Minus cos 2 theta, only exchange here. Minus cos 2 theta into cos 2 beta. Okay. Now 1 by 2. 1 minus cos 2 beta is, which we have already used here also. And similarly we can write here, only angle is changed. 2 sin square beta minus, here is the common, which is cos 2 theta. Then we get 1 plus cos 2 beta. 1 by 2. 2 sin square theta is same 2 sin square beta, sorry. Here cos 2 theta into 1 plus cos 2 beta is 2 cos square beta. Now if we multiply it by 1 by 2, then 2 cancel, here also 2 cancel, then we get sin square beta minus cos square beta times cos 2 theta. This is in right hand side. It means proved. Right hand side proved. Students, here is the important step which makes the problem very easy, and these are the formulas which also make our problem very easy. I think so. That's why by the same way you can solve the other type of problems also which are based upon it. Now again we are going to discussing the another problem having cube. The question is cos cube theta times cos 3 theta plus sin cube theta times sin 3 theta equals to cos cube 2 theta. This is the question. Now from left hand side we have to do it. Here cos cube theta into cos 3 theta plus sin cube theta times sin 3 theta. Here is the cube. Then I have already told you, if there is the power cube in the any kinds of trigonometric ratio, especially in sin and cos, then we have to use the coefficient 4. That's why here also we have to take the coefficient 4 by taking the whole coefficient 1 by 4. Then we can multiply it by 4. 4 cos cube theta times cos 3 theta plus 4 sin cube theta times sin 3 theta. 1 by 4. Now 4 cos cube theta is, here is the formula, 3 cos theta plus cos 3 theta times cos 3 theta plus 4 sin cube theta is 3 sin theta minus sin 3 theta times sin 3 theta. 1 by 4. If we multiply it by cos 3 theta, then we get 3 cos 3 theta times cos theta plus cos square 3 theta plus 3 sin 3 theta times sin theta minus sin square 3 theta. Now in these two terms, here is the coefficient, here is the coefficient 3. That's why we have to take the common 3. And these trigonometric ratio having a square have to be taken together. 1 by 4. Then 3 common in two identities, two terms. That's why here cos 3 theta plus sin 3 theta, sin theta is left, minus, sorry, plus cos square 3 theta minus sine square 3 theta. 1 by 4 3 sine A cos B plus cos A sine B it is the compound angle which you have already learned in grade 9 also. That's why sine A cos B plus cos A sine B is cos A minus B. A is 3 theta and B is theta. Plus cos square theta minus sine square theta is cos 2 theta, multiple angle. That's why cos 2 and in place of theta here is 3 theta. That's why in bracket we have to take 3 theta. Three cos 2 theta plus another important thing is here. Here is the angle 2 theta for cos and here is the angle 6 theta. But to make the like terms of the angle of cos, then we have to exchange the coefficient 2 and 3 here. Cos, it can be written as 3 times 2 theta also. Then the angle becomes same, 2 theta and 2 theta. 1 by 4, now listen, 3 cos theta. If we suppose this 2 theta is theta, then 3 cos theta plus cos 3 theta. It is the formula which we have already discussed. 4 cos cube theta, which is 2 theta. Then 4 cancel, we get cos cube 2 theta. This is in right hand side. It is also proved. Now another type of example also we can see. 3 number. Sine square alpha minus sine square beta divided by sine alpha cos alpha minus sine beta cos beta is equal to, in right hand side we have to prove alpha tan alpha plus beta. Now we have to start from left hand side here also. Sine square alpha minus sine square beta divided by sine alpha cos alpha minus sine beta cos beta. And as the previous, here are also square as well as product form. That's why in both of them we need coefficient 2 and we have to multiply it by 2 for numerator as well as for denominator. 2 sine square alpha becomes, which we have already discussed in the previous question. Then 2 sine square alpha is 1 minus cos 2 alpha. In bracket we can take 2 sine square beta is 1 minus cos 2 beta. Then 2 sine alpha cos alpha is sine 2 alpha. Common formula, it is the multiple angle. Minus 2 sine beta cos beta. Similarly, we can write it as sine 2 beta. If we open the bracket, then we get 1 cancel. Then 2 alpha cos 2 alpha becomes negative and cos 2 beta becomes positive. But as compared to alpha and beta, to write in the order, we have to take alpha at first according to the right hand side. That's why we have to take minus common. Cos 2 alpha, then minus plus minus cos 2 beta we can get here. And in denominator, sine 2 alpha minus sine 2 beta. And transformation formula also we have already discussed at first. Then if we use here C minus C, I have already told you C minus C is minus 2 SS. First it sine and the angle becomes 2 alpha plus 2 beta by 2. Sine C plus D by 2. Similarly 2 SS means again sine. Second angle is C minus D by 2, which is 2 alpha minus 2 beta divided by 2. Divide by s minus s, it is 2 cos c plus d by 2, same as the previous, plus 2b by 2 and sine 2 alpha minus 2 beta divided by 2. Then we can cancel these two. 2 cancel, minus minus plus, and here 2 common, alpha plus beta by 2, 2 cancel, cos alpha plus beta by 2, here also 2 cancel. That's why sine alpha plus beta divided by cos alpha plus beta is tan alpha plus beta, and it is in right hand side. It is also proved. For all type of questions here, these formulas are the very much important formulas. Always remember these and you can solve the problems, and you can try also. Another example we can take now. Sine 10 degree, sine 30 degree, sine 50 degree, sine 70 degree equals to 1/16. And we have to do from left hand side here also. Sine 10, sine 30, sine 50, sine 70. Here are the 4 identities, and out of 4, one identity having standard angle, and it has the value also. That's why firstly write down sine 10 into sine 30 is 1/2, and for the remaining 2, I have already told you, if the identities are in product form, then also we have to take the coefficient 2. That's why 1/2 and 2 and 50 degree and 70 degree, 2 different angles are here, and we have to write greater angle at first to make the problem easy. That's why like this we have to write 1/2 into 1/2, 1/4, sine 10 degree, 2 ss. We are already discussed here. 2 ss is c minus c, but here is minus, there is not negative sign. And here for the first angle a plus b, and for second angle a minus b, if we change product to sum. That's why for this only, for others, first one angle a plus b and second one a minus b, but lastly this means for 2 ss only, at first we have to write a minus b to change the negative sign, and for second angle then we have to take a plus b. 2 ss means c minus c, cos firstly we have to write a minus b, 70 minus 50, minus c minus c is minus, cos again, then a plus b means 70 plus 50. 1/4 sine 10. Now if we subtract, then we get cos 20 minus cos 120. Now we have to multiply it. Sine 10 cos 20 minus 1/4 sine 10 cos 120. Now here also in product form, that's why we have to take 1/2 to bring the coefficient 2, and greater angle firstly we have to write cos 20 sine 10 minus 1/4 sine 10, cos 120 is minus 1/2, 1/8, 2cs. 2cs is s minus s, that's why sine 20 plus 10, first a plus b, minus sine 20 minus 10, it is a minus b, minus minus plus 1/8 sine 10. We have to multiply it by 1/8 sine 30 minus 1/8 sine 20 minus 10 is 10 plus 1/8 sine 10. These are cancelled. Then 1/8 and sine 30 is 1/2. That's why we get 1/16. It is in right hand side. It also can be proved like this, and such type of problems you can solve at your home also. These are the ways. Here are the ways, and I think you can feel very easy. Now in trigonometry, Another is we have to prove the trigonometric identities according to the by using transformation formula as this, but conditional transformation formula. Conditional identities. Conditional identities means one of the condition have to be given, like a plus b plus c is equal to pi, or 180 also you can write it, a plus b plus c equals to pi by 2, etc. If the condition is given, then the trigonometric identities also can be proved, and this one chapter is very much important because generally one of the question will be asked from here. That's why for this also we can take one example. If a plus b plus c is equal to pi, prove that sin a plus sin b plus sin c is equal to 4 cos a by 2 cos b by 2 cos c by 2. If the condition is given, then firstly we have to use the condition a plus b plus c equals to pi. Then only 2 have to be taken in left hand side, then another one have to be changed into right hand side. Then we have to take sine and cos both for them. But in right hand side, here are the angles a by 2, b by 2 and c by 2. That's why here also we have to make by 2. It means dividing both sides by 2 like this. Then we get sine pi by 2 minus c by 2. Pi by 2 is 90, and this one is the formula 90 minus theta, which you have already learned in grade 9. 90 into 1 minus theta. If there is the odd number for as the multiple of 90, then we have to change the ratio. It means sine to cos, angle is c by 2, and 90 minus theta belong to first quadrant, and in first quadrant all are positive according to cast rule, CAST. Students are related to it also. Cos, we have to take cos also here. B by 2 equals to cos pi by 2 minus c by 2 equals to, here also same thing. That's why 90 into 1, it means odd. We have to write sine c by 2. First quadrant all positive. Then only we have to start from LHS, left hand side. Sin A plus sin B plus sin C. Now transformation formula I have already told you, S plus S here. For these two, having angle A and B we have to use, because A and B are in left hand side and C is in right hand side. That's why C have to be left alone and A and B have to be taken. S plus S is 2SC. For first, A plus B by 2, and second, A minus B by 2 as the angle, plus sin C as it is. 2 sin A plus B by 2 cos A minus B by 2 plus sin C. Now sin A plus B by 2 is, we have already found out, 2 cos C by 2. Cos, we have to separate the denominator. That's why A by 2 minus B by 2 like this we have to write. Plus, if we change this, then we have to use the formula of this also. Here is C by 2, here is C. It means sub multiple angle. Very easy. 2 sin C by 2 cos C by 2. Now, which one is common here? We have to find out it. Here is the common 2 cos C by 2. That's why 2 cos C by 2 is the common. Then remaining one, cos A by 2 minus B by 2 plus 2 cos C by 2 is common. That's why sin C by 2 is the remaining term. 2 cos c by 2 cos a by 2 minus b by 2 plus sin c by 2, again from the condition. Sin c by 2 is this one. It means cos a by 2 plus b by 2. Here we can use the transformation formula c plus c also, but for your easiness you can use the compound angle also. If you use compound angle, becomes very little bit longer, but it is very easier. 2 cos c by 2, then compound angle cos a minus b is cos a cos b plus sin a sin b plus cos a plus b is cos a cos b minus sin a sin b. These two are cancelled here. Then 2 cos c by 2 plus 2 cos a by 2 cos b by 2. Then after multiplying we get 4 cos a by 2 cos b by 2 and cos c by 2. This is in right hand side. This is the conditional formula. In the conditional formula also, the identities having square also will be there. That's why another example we are discussing here. Sin square a plus sin square b plus sin square c equals to only left hand side is here, right hand side itself will be obtained, and then we can write here also, because according to the question we have to know how have to be solved the problem. That's why right hand side is not given here. Solution. Again here also we have to use condition a plus b plus c is equal to pi. Students, I am the mathematics teacher as well as science teacher as well as the writer as well as related to the publication also. That's why always remember Pragya publication is the best publication to which produce the different type of varieties of textbook which are very much popular also. And now see here, as the previous, again we have to take a plus b here, then pi minus c in right side. Always remember, if there is the square term and if there is no square, then the angle becomes, if there are not square in the trigonometrical identities in left hand side, the right hand side angle becomes half of the left hand side. But here are the squares in each trigonometric identities which are in left hand side. That's why the angle in right hand side also becomes just same as in left hand side. That's why need not necessary to divide as the previous question. Directly we can take sine and cos separately. Sine pi minus c, pi is 180 degree, 180 is 90 into 2, 2 is the even angle, even multiple of 90 degree, and if there is the even multiple, then in place of sine we have to write sine again, same trigonometric ratio have to be written, and this is this belongs to second quadrant, and in second quadrants according to cast rule CAST, that's why sine is positive here. Second quadrant is the quadrant of sine. Or again cos have to be taken, cos a plus b equals to cos pi minus c equals to minus cos c according to cast rule. Now left hand side, sin square a plus sin square b plus sin square c. I have already told you, if there is the square, then in any kinds of trigonometrical identities If you get square in each identities, then always remember we have to take the coefficient 2. That's why here also we have to take the coefficient 2. 2 sine square a plus 2 sine square b for the trigonometric ratios having angle a and b only, because we have to change having angle a and b, plus sine square c as it is we have to write. 2 sine square a is 1 minus cos 2a plus 2 sine square b is 1 minus cos 2b plus sine square c. 1 by 2, 1 plus 1 2 minus common cos 2a minus cos 2b plus sine square c. 1 by 2, 2 minus, if we take minus common, then minus minus it becomes plus. Now here c plus c, I have already told you c plus c is 2cc. 2 cos 2a plus 2b by 2 cos 2a minus 2b by 2 plus sine square c. If we multiply it by 1 by 2, then 2 cancel in both terms, then we get 1 minus cos, here also 2 common and cancel, a plus b cos a minus b plus sine square c. Now we have to change this from the condition. Cos a plus b is minus cos c, that's why here becomes 1 minus minus plus cos c cos a minus b plus, here is cos c, and to take common this sign also have to be changed into cos, which is 1 minus cos square c. 1 plus 1 2 plus cos c is common, then we get cos a minus b minus cos c. And again from the condition, minus cos c is the cos a plus b, we have to write here also. 2 plus cos c cos a minus b plus cos a plus b. Again we can use the transformation formula as well as the compound angle, and I have already told you if you use compound angle becomes easier. Cos a cos b plus sin a sin b, cos a minus b is, then cos a plus b is cos a cos b minus sin a sin b, then sin a sin b cancel, then we get 2 plus, after adding we get 2 cos a cos b, then after multiplying we get 2 cos a cos b cos c. This is the right hand side, and we have to write this one term in right hand side. 2 plus 2 cos a cos b cos c. Like this, conditional trigonometric identities also can be proved by using the formulas which we are discussed here initially at the beginning. Now another one topic also we are going to discussing here, trigonometric equations. Trigonometric equations also have to be solved according to algebra, and after solving we have to solve for the angle also. This thing is different other as the algebra. One example, conditions for the to calculate the angle also will be given here, like theta, which is from 0 to 2 pi, it is the maximum range, and in the short question there may be up to 90 degree, up to 180 degree, etc. But in long question generally from 0 to 360 degree we have to find out, like this. One example, 2 root 3 sin square theta is equal to cos theta. As the solving of trigonometric equation, we have to make the identities same. We have to change cos to sin or sin to cos, but here is the square, that's why you can change sin to cos here. 2 root 3 1 minus cos square theta equals to cos theta. Now 2 root 3 minus 2 root 3 cos square theta is equal to cos theta, and all the terms have to be taken in one side and right hand side should be made 0 to solve the identities. Yesterday in algebra also I have already told you. That's why we have to take in same side but in order. 2 root 3 cos square theta, we have to change this in another side, plus cos theta is here, then 2 root 3 becomes minus 2 root 3 equals to 0. Now midterm factorization according to algebra. 2 root 3 times 2 root 3 is 2 to the 4 3, 4 3 is 12, and here is the minus sign in last. That's why after subtracting we have to find out 1, and here 4 minus 3, 4 3 is 12, 4 minus 3 is 1. Midterm factorization just. Two root 3 cos square theta plus 4 cos theta minus 3 cos theta minus 2 root 3 is equal to 0, or common 2 cos theta, then root 3 cos theta plus 2 is the factor, one of the factor, minus here is 2 root 3, here is 3 only. 3 means root 3 all square. It means 1 root 3 can be taken as the common. Then root 3 cos theta minus minus plus root 3 is common, 2 is left, 0. And again one expression is common expression, which is root 3 cos theta plus 2 and remaining 2 cos theta minus root 3 equals to 0. Either or. Root 3 cos theta plus 2 equals to 0, 2 cos theta minus root 3 equals to 0, or cos theta equals to minus 2 by root 3. Here cos theta is equal to root 3 by 2. 2 by root 3, this one value in terms of cos, trigonometric identity or ratio cos, there is no the standard angle. There are not any kinds of standard angle for the angle, for the value 2 by root 3. That's why we have to write here it has no proper solution. And for the second one, here is the value root 3 by 2 and it has the standard angle also. That's why here is plus sign. For cos, in which quadrants there are the plus sign? Firstly we have to mark here in quadrant system. And according to cast rule, first quadrant all are positive, as well as in fourth quadrant the cos is positive. It means here are the two quadrants where the cos theta is positive. That's why our cos theta equals to, in first quadrant its value is cos 30 degree, and in fourth quadrant we have to write cos 360 minus 30 degree. If the angle belongs to second quadrant, then we have to write 180 minus standard angle. In third quadrant 180 plus standard angle, and in fourth quadrant we have to write 360 minus standard angle. Always remember it. Therefore cos and cos can be eliminate here, then we can get theta equals to 30 degree and 330 degree. Therefore the required angles are angles are 30 degree and 330 degree. Again another example also we are going to discussing here. Cos theta minus root 3 sin theta equals to 1. As compared to the first example here are not any kinds of power. Here is the power, but only one power, not more than one. That's why according to algebra we cannot factorize it. And for this type of problem, by taking squaring on both sides also we can solve it, but the easiest way is by dividing with root over coefficient of cos theta whole square plus coefficient of sin theta whole square. This is the way. And here coefficient of cos theta 1 square plus coefficient of sin theta is minus root 3 square. 4 and square root of 4 is 2. Then we have to divide both sides by 2. By 2 equals to 1 by 2. Or 1 by 2 cos theta, we have to separate the terms, minus root 3 by 2 sin theta equals to 1 by 2. Or now here 1 by 2 and root 3 by 2 are the values of, for cos theta and sin theta, having standard angles also. And which one standard angle have to be used? We have to discuss one thing here. If this is the exceptional case, firstly, if there is the cos theta and negative sign, then always we have to use the similar type of trigonometric identities. Okay, always remember it. But in other cases, other than the such type of problem, for this type of problem, then we have to use opposite one. First, if here is the cos, then this one is standard angle, we have to use sine, and for this standard angle we have to use cos, because here it's sine, just opposite. But for this type of problem, means firstly cos and then negative sign, then we have to use similar one. That's why cos theta, this is as it is, and 1 by 2 is cos 60 degree minus sin theta, sorry, and this one is sin 60 degree is equal to 1 by 2. Cos A cos B minus sin A sin B is cos A plus B equals to 1 by 2. Again cos, here is the positive sign. It means again we have to find out the quadrants. For the trigonometric ratio cos theta, the positive quadrants, because positive value is here, that's why first and fourth. Cos theta plus 60 equals to, in the first quadrant 1 by 2 is cos 60 degree standard angle, and in fourth quadrant I have already told you 360 minus 60 degree. In this type of problem, then to find theta we have to subtract the 60 degree. That's why if here is plus, then another one in the first quadrant also have to be found out, which is cos 360 plus 60 also have to be calculated here, which is also belong to first quadrant. Then cos can be eliminated. 60 equals to 60, 360 minus 60 is 300, 360 plus 60, 420. If we subtract this 60, then 0 degree, 240 degree and 360 degree. These are the angles. Students, today we discussed 3 chapters of the trigonometry, more than 3 also, because in transformation formula there are the different chapters which are given in your textbook also. And I was given here different type of formula which can be used very easily to solve the trigonometric identities. And if you apply also, then you will get the interesting formula or interesting way to solve the identities. Okay, and according to such type of example, then you can do at your home also, and you have to do also, because your examination will be in near future after lockdown. That's why enjoy yourself and try to solve the problems by the way which I am giving you now. And today in trigonometry we discussed here, that also helps to you, I think so. and best of luck. You have to do yourself, then only you can solve the problems. And tomorrow we will discussing uh, in the science, which is also difficult subject, and tomorrow I will give you some of the important ideas to solve the different type of questions in belonging to chemistry. Okay, thank you very much. Enjoy yourself.